Good evening. Tonight's lecture is going to be on the technology infrastructure of the Internet. In this lecture, we'll cover the history of the Internet, give an overview of its technology architecture, which is that of a combination of packet-switched networks, and we'll go through how various protocols that we use commonly, such as the web and email, work. We'll also go into markup languages and drill down on HTML and how links with HTML work. Go through the various internet connection technologies and discuss the next generation of the internet. More internet users are using smartphones or tablets. We have a high mobile device usage, and that is taxing existing technologies and is threatening to overload networks. The current solution is for wireless providers to add more cell phone towers. That's expensive, and locations can be hard to find. With mobile data traffic expected to triple in the next few years, the search for alternatives is underway. Computer networks are any technology allowing people to connect computers to each other, and that is the basis of the Internet and the World Wide Web. Internet with a small I is a group of interconnected computer networks. Internet with a capital I is the existing network of networks all over the world. The World Wide Web is a subset of internet computers that have this HTML graphic program capability that really enhances usability. The Internet began in the early 1960s. The Defense Department was concerned with nuclear attacks at that time, and in that era we had powerful large mainframe computers, and we had leased telephone company lines that established a single circuit between the sender and the receiver. That was a risk in the event of that type of cataclysmic nuclear attack, because there's a single connection, that single circuit, that was a single connection risk. So the solution they came up with is to communicate over multiple channels using packets. And this is a throwback to the old telegraph networks of the 1800s, when people would go to a telegraph office and they would get a message, and then the telegraph operator there would send it over the wire, and it could go to many different telegraph operators depending on if the line was down. So if it went to, say, from Chicago, and it was supposed to ultimately go to New York, it might first go to Cincinnati, and then it might then go to New York. But if the line between Cincinnati and New York was down, then the packet could be rerouted and go to Cincinnati to Cleveland to Pittsburgh to New York, for example. So instead of having a continuous communication circuit that you send the message, you establish a connection between yourself and the destination. You break your message into packets and you send them according to what's available. And that also led to the ability to increase efficiency, because you could used protocols that monitored network traffic and then routed over the least used lines. In 1969, the Advanced Research Project Agency, ARPA, formalized ARPANET, and that became ultimately the Internet. The primary use was academic research in the 1970s and 80s. New uses for the Internet started after that. Email became widely used. Military and educational research users continued to grow, and mailing lists began to appear. In 1979, the Usenet was created, and Usenet stands for Users Net News Network, and it continues today with news groups. Network applications improved, and an increasing number of users started putting network applications on the Internet between 1979 and 1989. And during that period, there was a realization about security problems. In 1980s, the personal computer use exploded, and academic and research networks were merged into the Internet. Around that time, the commercial use of the Internet began. The National Science Foundation provided funding, and larger firms built networks with leased telephone lines. In 1989, the National Science Foundation permitted 2 commercial email services, MCI Mail and CompuServe. With those 2, commercial enterprises could send email, and research educational communities could send email directly to MCI and CompuServe, and then it would be routed to other organizations as well. In 1991, we saw the growth of the Internet. The NSF it encouraged further commercial Internet activities, and the privatization of the Internet was completed in 1995. So at that time, it was no longer the ARPANET, it was the Internet formally. Operations were turned over to privately owned companies. The Internet is based on network access points. Network access providers sell Internet access rights directly, but most commonly they sell them through Internet service providers. So at our homes, we typically go through an Internet service provider who then connects to the network access provider. There's been a consistent and dramatic growth in the number of Internet hosts, computers directly connected to the Internet, to more than 1 billion today. The Internet of Things is a growing phenomenon, and it's estimated that by 2020 there will be 40 billion devices that are considered part of this Internet of Things. Connection of devices not used by people is rapidly increasing, and that is what we call the Internet of Things. Switches, optical scanners, and sensors can be connected to the Internet and used to automatically manage environmental or security issues. Some business transactions can be conducted without human intervention. And again, the Internet of Things is the term used for these devices and for automatic transaction processing. There's about 10 billion devices now considered to be part of the Internet of Things, and it's expected to reach 40 billion by the year 2020. And here we see the growth of the Internet in this graph, and it follows the typical technology introduction S-curve. It starts out relatively slowly, then it gains very quickly, reaches an inflection point, and then begins to increase more slowly, and eventually will plateau. Some of the technologies on the Internet include packet-switched networks. A local area network is a network of computers that's close together. And a wide area network is a network of computers connected over greater distances. A telephone call establishes a single connection path between the caller and the receiver, and then it transmits data along that single path or circuit. Circuit switching is centrally controlled single connection model. And as I mentioned, it's not resistant to failure because a break in any circuit segment causes interruption and data loss. Packet-switched networks breaks your messages, be it files or email messages, into smaller pieces called packets. They're labeled each packet with the origin, the destination addresses, and the sequence of the packets to reassemble them into the original message. They travel along these interconnected networks until reaching the destination. And as I discussed earlier, they can take different paths depending on the availability of circuits or depending on the load on various circuits. They may arrive out of order as a result. The destination computer collects the packets and uses the sequence number to reassemble the packets into the original file or email message. Routing packets is another technology that's used on the Internet. And routing computers forward each packet. And they use a combination of routers, gateway computers, and border or edge routers. Routing algorithms are applied to information stored in routing tables, also known as configuration tables. Hubs, switches, and bridges move packets from one part of the network to another. Routers connect networks to other networks and usually perform a translation function. The Internet backbone is the telecommunication lines and the routers between the Internet's main access points. You have private and public networks. A public network is available to the public and does not provide much security as part of its basic structure. A private network is a leased line connection between two organizations that physically connects their computers or networks together. A leased line is a permanent telephone connection between 2 points. The advantage of a leased line is security. The drawback is cost. Virtual private networks are an attempt to use public networks and provide the advantages of private networks. A VPN is a connection via public networks to send data in a way that protects it as well as a private network, and also at a lower cost. It uses IP tunneling, that is, encapsulation systems, to create a private passageway through the public internet. encapsulation encrypts packet contents and places it inside another packet. This is an IP wrapper, that the outer packet is an IP wrapper. It's virtual since connections seem permanent, but it's actually a temporary connection through the public network. Intranets are an internal network. It's like an internet within the boundaries of an organization. It uses the same protocols as the internet does, but it's intended for use within the organization only. So it's an interconnection of private networks within an organization. An extranet extends an intranet to include organizations outside of the company, and it incorporates these other networks with outside entities. Technologies are public networks, private networks, and VPNs that are used to create these extranets. The internet protocols, first, the protocol is a collection of rules to form a process. Computers that communicate with each other must use the same protocol for data transmission. There's a network control protocol that was used by ARPANET. The internet protocols can follow two types: an open architecture, which the internet core is based on open architectures. It uses a common protocol, and it's the open architecture is what's contributed to the internet's success. You can also have a closed architecture, also known as a proprietary architecture, and that's where a vendor creates their own protocol that gives them a commercial advantage, and they argue it also gives customers an advantage as well. TCP/IP is one of the combination of protocols used on the internet today. It really consists of two protocols. The first is the transmission control protocol, TCP. That's the first part of it. And that controls message disassembly into packets before internet transmission. It likewise controls packet reassembly into the original form at the destinations. The IP, that's the second part of the protocol combination, specifies the addressing details for each packet. It labels the packet with the origination and destination addresses. IP addressing is today primarily based on Internet Protocol version 4, IPv4, and that's been used since 1991. IP address in this version is a 32-bit number that's used to identify computers. Obviously, we know the computers use the binary number system, so 32-bit numbers give us the possibility of 4 billion different addresses. The router breaks messages into packets that contain the source and destination IP address. It uses a dotted decimal notation, so it appears as 4 numbers separated by periods. 3 organizations assign IP addresses. Obviously, there's a lot of new devices entering into the internet sphere, and that's creating a high demand for IP addresses. The last IPv4 addresses were allocated in the summer of 2015. For a long time prior to that, people realized we were going to run out of IPv4 addresses, and so they used various techniques like subnetting to help extend the lifespan of that IPv4. So, for example, in your home, you'll typically use the same IP addresses as your neighbor. It's only when you get out into the public internet that it's translated into a unique IP address. The real solution to the problem will be IPv6. And that's the Internet Protocol version 6 that will replace IPv4 and uses a 128-bit number for the addresses. That's going to dramatically increase the number of addresses available. The number is actually, they don't have a name for it, but it's 34 followed by 37 zeros. And it uses a more complex hexadecimal notation system rather than the easy-to-read decimal numbers we're used to today. Electronic mail protocols are another technology that sees widespread use on the internet. Email has to be formatted according to a common set of rules. An email server computer is devoted to email handling. It's the software that stores and forwards email messages. An email client software reads the email messages and gives users the ability to compose and send email messages. It communicates with the email server software, and there's also many email services that are offered by websites, for example, Google. Standardization and rules are essential in order for this email system to work. There's several common protocols used for email. The first is the Simple Mail Transfer Protocol, SMTP, and that specifies the mail message format and describes mail transmission. Then we have the POP, Post Office Protocol messages, and that sends mail to the user's computer and decides whether or not to delete it on the server, and also asks the client if the email has arrived. Another protocol is the Multi-Purpose Internet Mail Extensions, MIME, and it's a set of rules for handling binary files in an email message. Then we have the Interactive Mail Access Protocol, IMAP, and that performs the same basic POP functions but has some additional features. Here we see the schematic of the Internet's operations. You have various organizations, companies, institutes, universities, and so on. They've got their internal LANs. They may even have wide area networks. They can then connect these elements to a gateway router that is on the internet, and the gateway router is connected to backbone routers that are managed by the common carriers. The backbone routers then can communicate with each other, and they'll have those tables of information that we talked about, the routing tables, and they'll know if company A wants to send to company G. They'll have the routes that are possible to get there, and they'll have current traffic information, and they can make a decision on what's the best way of getting the message that they receive from the router, the gateway router of company A, and get it to the gateway router of company G. So let's continue talking about technologies used on the internet. We have web page request and delivery protocols. Web client computers run web client software, and that's typically known as a browser. Some common examples are Microsoft Edge, Microsoft Internet Explorer, Google Chrome, Apple Safari, Mozilla Firefox. And they send web page requests to other computers that are web servers. The web server computer runs web server software, and it receives requests from the web clients, and it sends files back to them. It's a client-server architecture, a combination of client and server web computers. It uses the hypertext protocol, HTTP, and that's an internet web page delivery set of rules. The web page request is made using a web browser, and it's going to follow the following format. The user will type in the protocol name, be it SMTP, FTP, HTTP, followed by 2 slashes and a colon, and then it'll give the domain name after that. This combination is also known as a Uniform Resource Locator, URL, and it's a combination of the protocol name and domain name. It's used to locate resources, for example web pages, on another computer that would in this case be a web server. So the emergence of the World Wide Web, the web is software running on internet-connected computers that has a graphical user interface and uses hypertext. It generates a lot of network traffic. We mentioned email as one of the protocols. The web protocol is the largest single traffic category on the internet. Outpaces email, outpaces file transfers, or FTP, and other data transmission traffic. The web resulted from new ways of thinking about information storage and retrieval. The key technological web elements are hypertext and graphical user interfaces. Some of the history of the hypertext and how it developed. In 1945, Vannevar Bush, in an Atlantic Monthly article, proposed a visionary idea about future technology use that was the forerunner of a page linking system. In 1960, Ted Nelson described a page linking system, and in the 1960s, Douglas Engelbart developed an experimental hypertext system. In the 1980s, Ted Nelson published Literary Machines, and he outlined a project called Xanadu on an online global hypertext publishing and commerce system that obviously became the World Wide Web. In 1989, Tim Berners-Lee proposed a development project to provide data sharing functionality and develop the visions that these other gentlemen had discussed were made concrete with a hypertext server program code. So Tim Berners-Lee developed the hypertext server program software. Hypertext servers store files written in hypertext markup language, or HTML, which is used for the creation of web pages. HTML is a language that includes a set of codes or tags attached to text, and those are used to describe relationships among text elements and to format. A hypertext link or hyperlink in a document points to another document in another location, or it can also point to another location in the same document. The graphical user interface for hypertext is what made the web extremely popular, and it really exploded the use of the internet, which until then had been based on fairly arcane console text-based command sets. But with a graphical user interface, the ease of use just was phenomenal, and it became widely popular. The web browser is the software that does that. It's software that lets users read or browse HTML documents and move from one HTML document to another through text formatted with hypertext link tags in the file. It's a graphical user interface, a GUI, and that presents program control functions and output to users and takes input from users in a very friendly manner. And it also allows you to incorporate pictures, icons, videos, and other graphical elements. The World Wide Web is Berners-Lee's name for a system of hyperlinked HTML documents. It rapidly gained acceptance in the scientific research community, and in 1993, 4 years after he published his server, the first GUI program was made available called Mosaic that could read HTML. It used HTML hyperlinks for page-to-page navigation. The first web browser, Mosaic, was widely available for personal computers, and it's still in use today. Its descendant is Firefox. It provided easy access to internet information through a system of pages connected by hyperlinks. A lot of businesses realized there was a profit-making potential through e-commerce with this technology. Netscape was founded in 1994. They developed the Netscape Navigator web browser, and of course that was based on Mosaic. Shortly after that, Microsoft came out with Internet Explorer, and then Netscape went out of business, and Mozilla took over the Navigator and called it Firefox. The number of websites has grown more rapidly than the internet itself. There's more than 800 million websites and over 1 trillion individual web pages. In 1 year, from 2010 to 2011, the number of websites doubled. And here we see the growth of the World Wide Web, and we can see how rapidly it grew in relation to the internet itself, and how from the period of 2008 to 2014 it was skyrocketing in its growth. The deep web is a store of information available through the web. There's potentially trillions of pages of web information available using the deep web. However, it's difficult or impossible to search because it's not picked up by the typical search engines. It's pages out there that have never been requested and therefore remain hidden. The web provides access to customized pages created in response to a user's query. They can pull content from databases, for example, and there's a lot of those type of pages out there that are this deep web that just are not picked up by the search engines, and you may not be able to find them unless you know how to get directly to those pages. Domain names are another important part of the web. The dotted decimal notation number is rather difficult to remember, so domain names are sets of words that are assigned to a specific IP address. For example, www.shepherd.edu would be a domain name, and it consists of 3 parts separated by periods. The top level domain, in this case .edu, is the rightmost part. The Internet Corporation for Assigned Names and Numbers handles this, and that's known by its abbreviation ICANN. Markup languages are another essential part of the web. Text markup languages specify a set of tags that are inserted into the text. Markup tags provide formatting instructions that web client software understands. Most commonly used markup language, the most commonly used markup language, is HTML. And it's a subset of the generalized markup language. The World Wide Web Consortium, the W3C, maintains web standards. There's also an extensible hypertext markup language, XHTML, that's used on the internet as well. So what is a hypertext markup language? Well, hypertext elements are text elements that are related to each other, and HTML is a prevalent markup language to create web documents. HTML version 5 was released in 2014. As mentioned, SGML is a meta-language that is used to define other languages, including HTML and XML. HTML tags are interpreted by web browsers and used to format the display of the text enclosed by the tags. Tags are enclosed by angle brackets, and most have an opening tag and a closing tag that format the text between them. The closing tag is preceded by a slash within the angle brackets. Users may customize tag interpretations so that different browsers display tagged text differently. Tags are usually written in lowercase letters. One-sided tags require the opening tag only. A common example of that is a line break. Some two-sided tags have an optional closing tag, and an example of that would be a paragraph tag. An opening tag may contain one or more property modifiers that refines how the tag operates. Other frequently used HTML tags allow web designers to include graphics and format text as tables. So here we see a picture of some commonly used domain names. edu, top-level domains, edu for educational institutions, .mil for the military, .com for U.S. commercial. And here we see the standard generalized markup language, SGML, and two of its descendants are HTML and XML. They were combined to form XHTML. And here we can see text that has been marked up with HTML tags. And you can see the paragraph tag. The closing tag's optional, but in this case it does have a closing tag, and it's the meaningful text for this particular activity. Here we can see the effects of the tags. The top line is a heading 1 tag. The next line is a heading 2 tag, a heading 3 tag, the actual paragraph itself with some bolding and so on. You can get bulleted and numbered lists as well. You can read a document linearly, which means you're going from one page to the next page. But with a hypertext document, you can read it in a variety of different orders, depending on your interest and where you want to go next. So there's 3 common web page organizational structures. There's linear, where one page points to one other page only, and that's useful for forms where you're going to go from part A of the form to part B of the form to part C to part D. You also have a hierarchical structure like we might have for our website organization, where you go to a landing page, and from there you can go to many other pages, and each one of those other pages can lead you to many other pages as well. And of course there's a hybrid structure for that as well. So we've talked about hypertext markup language and HTML tags. HTML links, hyperlinks on interlinked pages form a web of those pages. A linear hyperlink structure reads web pages in a serial fashion, one page to one other page in a sequence, and it works well when the customer fills out a form. Hierarchical hyperlink structure uses an introductory page, a landing page, a home page, or a start page that links to many other pages. And there's often a site map function that lists the links and the pages available and how they're linked for a site. HTML creates hyperlinks using anchor tags. A cascading style sheet is a set of instructions that gives web developers control over displaying page formatting. Cascading style sheets can be applied to each web page, and they can be applied one on top of another. The extensible markup language XML was developed because HTML is not a good tool for presenting large amounts of business data, so the designers turned to XML. So XML is designed to present large amounts of business data to another program rather than to another person, but it can be used to to send information to a person as well. Like HTML, it uses paired start and stop tags to define the structure of a collection of data. It includes the data management capabilities HTML cannot provide. Its greatest strength, and also its greatest weakness, is that it allows users to define their own tags. Many companies have agreed to common standards for XML tags, and these are known as data type definitions, or DTDs. They're also known as XML schemas. The available DTDs, or XML schemas, include Legal XML for the legal profession, MathML for mathematical and scientific information, Extensible Business Reporting Language, XBRL, for accounting and financial information systems. The set of XML tag definitions is called an XML vocabulary. XML files are usually not intended to be displayed in a browser. Extensible Style Sheet Language, XSL, contains formatting instructions. So with XSL, you have an XML parser that reads an XML file and makes it presentable for a device screen for an end user. So here we see a country list marked up with HTML tags. And you can see they have header 1, header 2 for various hierarchical organizations. How these particular tags would appear in a web browser. Here's the same country list that's marked up with XML tags. And you've got your declaration of the version, and then a root element and further definition of country names within the country list. And this is what the raw XML would look like when displayed in a browser. But as mentioned, you can create an XSL that provides a better presentation for it. So here's how processing is conducted for web pages from an XML database. The web client will send a request to a web server for an XML page. The web server will go to an XML database and retrieve that information. An XML parser will format the data using a style sheet, XSL, that matches the web client device's formatting needs. That parser then sends that document back to the web server, and the web server then in turn delivers it to the requesting client. So, connectivity, internet connection options. The internet is a set of interconnected networks. Organizations connect computers using a network. Of course, many of us have our home computers connected using a network. Mobile phones are connected to our wireless carrier's network also. Internet access providers, they're also known as internet service providers, IAPs or ISPs, provide internet access to individuals, businesses, and other organizations. And they usually offer several connection options. Common connection options are voice-grade telephone lines, various types of broadband connections, leased lines, and wireless. Bandwidth is the amount of data traveling through the communication medium per unit of time. The net bandwidth, not as in the internet, but as in gross or net income, the net bandwidth is the actual data transmitted per second. Symmetric connections provide the same bandwidth in both directions. Asymmetric connections provide different bandwidths for each direction. There's two types of bandwidth in an asymmetric connection. An upstream, that's the upload bandwidth, and a downstream, that's the download bandwidth. Voice-grade telephone connections, used in the early days of the web. POTS, the plain old telephone service, uses existing telephone lines and an analog modem. And you had bandwidth between 28 and 56 kilobits per second. Most people use higher bandwidth connections. Today, we have speeds greater than 200 kilobits per second, and these are known as broadband services. Digital subscriber lines, DSL, is a higher grade of telephone service, and it provides asymmetric digital subscriber lines. You can get bandwidths for up to 640 kilobits per second upstream and 1 to 15 megabits per second downstream. Cable modems connect to the television cable. The bandwidths for your typical client to server can be 500 kilobits per second to 15 megabits per second, and downstream can be as high as well over 10 megabits per second. Connection bandwidths vary with the number of subscribers that are competing for the shared resource, which is, of course, the cable itself. Lease line connections. Large firms can connect to an internet service provider using higher bandwidths leased from communication carriers. They're classified by the equivalent number of telephone lines, and a DSO, a DS0, digital signal 0, carries one digital signal of 56 kilobits per second. A T1 line, also known as a DS1 line, carries 24 DS0 lines, or 1.544 megabits per second. T3 or DS3 line carries 44 megabits per second. Technologies also use frame relay, asynchronous transfer mode or ATM, and optical fiber instead of copper wire. And the bandwidth is determined by the optical fiber class. Wi-Fi or wireless Ethernet. The most common wireless connection technology uses the 802.11 protocol. The latest version is the 802.11ac with bandwidth ranges up to 2.5 gigabits per second and a range of 500 feet. The speed is impacted by the objects the signal must pass through. A wireless access point, or WAP or WAP, transmits packets between Wi-Fi equipped computers and other devices within range. Devices are capable of roaming or shifting from one WAP to another without human intervention. Hotspots are wireless access points that are open to the public. Bluetooth is a low bandwidth technology, usually 722 kilobits per second, designed for personal use over short distances. It's useful for wireless synchronization and printing. Devices consume very little power and can discover each other and exchange information automatically. There's also ultra wideband, or UWB, that provides bandwidth up to 480 megabits per second and connections over short distances. Fixed point wireless is used in rural areas without cable service. It's a system of repeaters to forward a radio signal from your internet service provider to customers. Repeaters are transmitter-receiver devices, also known as transceivers, and it uses mesh routing. It directly transmits Wi-Fi packets through short-range transceivers, and they're located close to each other. You also have satellite microwave, and that's where you make connections to the internet possible, and this is for the rural areas. Often it's the first time you make internet connections possible. It uses microwave transmitters that provide upload bandwidths in the range of 120 kilobits per second to 5 megabits per second, and downloads in the range of 1 to 16 megabits per second. Installation cost has decreased due to improved technologies that allow self-installation. It's offered by airlines, and it was once the only wireless internet access that was available, but now there's other options as well. Mobile telephone networks. The number of mobile telephones exceeded the world population for the first time in 2014. There was almost 8 billion mobile phones in use. One of the technologies used on mobile telephones is text messaging, or SMS, short message service. Most people today use 3G, which is a wireless technology that provides 2 megabit per second download and 800 kilobit per second upload speeds. Or they use 4G that increases that to 14 megabits per second download and 8 megabits per second upload. 5G is being introduced. And here we see a variety of internet connection options, and the range of upstream and downstream bandwidth, the number of simultaneous users, startup costs, and continuing monthly costs for internet connection options. The next generation of the internet, Lecture2 is an advanced research network created in 1996 as a replacement for the ARPANET laboratory. Experimental networking technologies are being used there. It's a test bed for them. It's looking into high end of bandwidth spectrum, 10 gigabits per second. And right now, some universities, medical schools, and CERN are using it. The focus is mainly on technology development right now. There's also the semantic web, and the semantic web project has a goal of blending technologies and information. Web pages are tagged using XML with meanings. It uses software agents, which are intelligent programs, to read the XML tags to determine the meaning of words. The set of XML syntax standards are known as a Resource Description Framework, or RDF. Obviously, the development of the semantic web is going to take many years, and they're starting with ontologies for different subjects. Well, that concludes our lecture this evening on the Internet, its history, and the overview of the technologies used. And we look forward to seeing you on the weekly forum. Good night.